minimum that the sun can appear is going to be the diameter of the sun divided by the farthest that the sun can be, which one was the aphelion, which one was 1.52 times 10 to the 8th. And that one is 1.392 divided by 1.52 divided by 100, 0.00915789 radians divided by pi multiplied by 180, 0.5247. So usually what we're getting is somewhere in the vicinity of about a half a degree. Half a degree, which 1 degree, remember, is 1/360th of a circle. So the angular diameter of the sun and the moon are roughly in the vicinity of a half a degree, but they vary a little bit more than half a degree, you know. And then in the case of this one, it was a little bit less than half a degree, okay. The minimum that the sun can be is 0.5247 times 60, that's 31.48 arc minutes. Okay, so let's put this all together. So you can visualize here. The minimum for the sun is 31.48 arc minutes. The minimum for the moon is 29.47 arc minutes. The maximum for the sun is 32.55. So the sun is always more than half a degree, right? Because 30 arc minutes is half a degree. So it varies from 30.48 to 32.55, so it doesn't vary a lot. Whereas the moon goes from 29.47 to 32.89. So look at the difference here. That's a difference of 3 arc minutes. So the moon, in going from perihelion, going from perigee to apogee, varies its size by 3 arc minutes, which is roughly, if you take the difference of this and divide it by their average, that's about 3/30, which is 10%. So that means the moon, during the course of the month, varies in size by about 10% when it's close to us to when it's far from us. The sun, however, only changes by about 1 arc minute. The difference between this is about 1, right? So for the sun, we have roughly about 1 divided by, and then the average of the sun is about 30, 31. So I'm going to do 1/31. So roughly about 3%. So throughout the course of the year, the sun appears 3% bigger and 3% smaller. In January, the sun is going to appear 3% larger. It's going to be closer to us by about 3%. In July, it's going to be farther away, so it's going to be about 3% smaller. The moon during the course of the month is going to change in size by 10%. Now let's bring this to the topic of solar eclipses. Okay, when the moon happens to be a new moon phase, right? So let's say this is the Earth, this is the moon, and here is the sun. So the idea is, can the moon totally cover the sun? Is the moon sufficient to cover the sun? Well, if the moon is maximum 32.89, that's more than sufficient to cover the maximum sun, and it's sufficient to cover the minimum sun. So we can get a total solar eclipse whenever the moon is in its max. When the moon is at its min, can it cover the sun when the sun is at max? Well, of course not, because it's 3 arc minutes less. Can it cover the sun when the sun is at minimum? So the problem therefore occurs when the moon is at its minimum. That means when the moon is far. When the moon is far from us, it can't even cover the sun when the sun is at minimum. Okay? So here's what ends up happening. This is known as an annular solar eclipse, not annual. So from our point of view, the moon looks like this, and then you get the sun looking like this. Okay, so the moon can be centered right in the middle of the sun. It could be what it's called its node. It's still not covering the sun. You have this edge of the sun appearing. How big is that edge going to be? What's the biggest it can be? This is known as an annular solar eclipse. And it comes from the Greek word annus, which means ring. You see the ring here? Leaves a ring right here. So the biggest, so if the minimum that this is 29.47 arc minutes, and if the biggest that the sun can be, is 32.55 arc minutes. Okay, how big is the ring going to be? What's the largest that the ring can possibly be? Well, we subtract them, right? 32.55 minus 29.47. Okay. And we get 3.08. And we divide that by 2. 1.54. So we can say the thickest that an annular eclipse ring can be, it can span a width of 1.54 arc minutes on either side. 1.54 arc minutes here, 1.54 arc minutes here. Otherwise, if the moon is closer to us, it's going to start appearing bigger, and then you're going to get a total solar eclipse. So you could see here how some geometrical analysis helps us see the distinguishing features of a total solar eclipse from an annular solar eclipse. Thank you.